This video is going to discuss the concept of standard deviation, both what it is and how to calculate it by hand. Range is one simple and imprecise way to measure how spread out data is, and we talked about this in one of the previous videos. Standard deviation is a much more precise method for measuring the spread of data. When we did our video on range, we saw that various sets of data can have the same range, but have different numbers. In this case, range only tells us a little bit about how spread out the data is. Standard deviation is a much more accurate way to measure the spread of data, regardless whether it is spread evenly or not, and regardless whether there are outliers as part of the data set or not. Standard deviation is a fancy calculation that takes every single data value and compares how far away it is from the mean. Then it takes all of these distances away from the mean into consideration to give you a kind of average distance away from the mean for that particular set of data values. It's not exactly an average distance, but it's kind of sort of that idea. If you think of it that way, that will be fine in terms of your understanding of a definition. We can calculate standard deviation both by hand and with a calculator. I will go over both methods, but this video will focus on how to calculate it by hand, and the next video will go through calculating standard deviation for the same example we use in this video, but using a calculator. The by hand method to calculate standard deviation uses a formula, and this formula will be given to you on your formula sheet for this course. Here's the formula. Now I know when you see it, it looks really intimidating and kind of scary, but we're going to define what each piece means, and we're going to work through an example, and you'll see it's not so bad. So the very first symbol that you see here, this guy, is the symbol for standard deviation. That is the Greek letter sigma, and we always use that to represent standard deviation. So anytime you see that, you should know what that symbol means. The symbols in this kind of formula might seem very complicated, but math is just a language with symbols that represent words. Each symbol has a meaning. Like I said, sigma was standard deviation. Sigma. Then we have the sum of symbol, and that indicates that we have to add whatever is beside that symbol, the list of values. F refers to the frequency in this case. So how often does each value occur in the data set? X represents each piece of data in our set. X bar is the mean of the set of data, and X bar, we call it X bar because it has the line on top of it, so that's where the bar comes from. And N is the number of pieces of raw data. So the standard deviation is calculated by taking the square root of the sum of the difference between each data value and the mean squared, all divided by the number of data values. I know that still sounds kind of intimidating, but we're going to go through an example, and it should seem a little bit less bad after we've seen the example. So, here's our question. At the end of the school year, you got all your grades for your core courses, and you wanted to know your average and standard deviation for your courses. In English, you scored 82%. In social studies, you got 75%. In math, you got 85%. In biology, you got 87%. In chemistry, you got 80%. And in physics, you got 76%. So before we calculate the standard deviation, we always have to calculate the mean or the average. Just to quickly refresh your memory, the mean is calculated by adding up all of the data values and then dividing that total by the number of data values. So we'll calculate the mean here. That means our mean, represented by this X bar symbol, is all of our scores. 82 plus 75 plus 85 plus 87 plus 80 plus 76. There they are. And there are 1, 2, 3, 4, 5, 6 of these scores, so they're all divided by 6. So we add up all of the top numbers in our calculator, we'll find out that they total 485. We divide that by 6, and we're going to end up with a mean of 80.83. So we now know that our average is about 80.83%. Yay, we are honor students. However, we want to know how consistent we were from course to course, and that's where standard deviation comes in. It will tell us how spread out our scores are. Are they very similar in all of our classes, or are they very, very far apart and we're much stronger in some subjects than other subjects? So now we need to apply our scores and our mean to the standard deviation formula. Please be aware that the frequency of each score is 1 because no score is repeated. Or in other words, every single score in our data set is only happening one time. So they each have a frequency of 1. So we copy out our formula for the standard deviation. That's the same formula we saw on the last page, and now we're going to start subbing numbers in. So here we go. Our standard deviation, we take the first score, subtract the mean squared, plus the second score, subtract the mean squared. So these are our distances away from the means. The third score, 85, and its distance away from the mean, so subtract the mean and then square that answer, and on for all 6 of our scores, all 6 of our grades. And we add all of those square differences up, and then divide by 6 and take the square root of the answer. So if I typed that entire top line here into my calculator exactly as it is, just the top line, so not the square root sign, not the 6, into my calculator exactly as it is, and hit the enter or the equals button, I'm going to get approximately 114.83. And so I need to take that value, divide it by 6, and that will give me my standard deviation in the end. And that works out to be 4.37. So the square root of that 114.83 divided by 6 works out to be 4.37. And what that means is the standard deviation is 4.37. That tells us that most of our scores should be within 4.37% on either side of the mean or the average. Or in other words, most of our scores should be within mean plus 4.37 and mean minus 4.37. And you're very welcome to go and add 4.37 to 80.83 and subtract 4.37 from 80.83, and you'll see that most of these 6 percentages do lie within that range.